Hello class, this is lesson 10-4 in your textbook, and today we're going to be dealing with inscribed angles and polygons. So first we need to talk about what an inscribed angle is. So I've drawn a circle here, and an inscribed angle is an angle that is formed when one of its points, well I guess the main point, the vertex of that angle falls on the outside of the circle. And the arc that is formed then from where the two rays are crossing the circle is called the intercepted arc. Okay? And there's some valuable information just from knowing that we're going to learn in some of our theorems today. So let's talk about Theorem 10.7. So Theorem 10.7 says that the measure of an inscribed angle, so the measure of this angle right here, is 1/2 the measure of the intercepted arc. So that means that if I can find the measure of either one of those, either the arc or the angle, then I can find the other. So let's just write this down, that the measure of angle ADB is 1/2 the measure of the arc AB. Okay, so why don't we go ahead and do an example related to this. So I've drawn a circle here, and I've labeled a few things in the circle. I've labeled that this inscribed angle is 50 degrees, and also that this intercepted arc is 42 degrees. So first I want us to find the measure of angle RTS. So RTS, so that's this angle right here. So the measure of angle RTS, based on the theorem that we just wrote down, should be equal to 1/2 the measure of its intercepted arc, which is RS. So the measure of RS. And I know that it's 42 degrees. So 1/2 of 42 degrees is 21 degrees. So that means that this angle down here is 21 degrees. Easy. So now why don't we find the measure of arc QR. And so looking here, it may seem like you don't really know what that is, but I want to point out a couple things. I can find the measure of arc QT, that intercepted arc, and since this whole chord RT is going straight through the center, that means it's a diameter, and the arc all the way stretching around from T to R should add up to 180 degrees. So if I find part of it, I can subtract that from 180 to find the remainder. So let's go ahead and use that thought process. So the measure of TQ is equal to twice the measure of the angle QRT. And that's 50 degrees, which means that the arc itself is 100 degrees. So since the measure of TQR, that arc is 180 degrees, I can subtract the 100 degrees from it, and that will give me 80 degrees, which is the remainder, the measure of QR. And that's it. So we found our two answers. Awesome. Let's go ahead and move on. Theorem 10.8 says if two inscribed angles of a circle intercept the same arc, so this first angle, ADB, is intercepting the arc AB, but then the second angle, ACB, is also intercepting the same arc AB, then the angles themselves are congruent. Okay. So in this case, angle ADB is going to be congruent to angle ACB. Awesome. So now we're going to talk about what an inscribed polygon is. An inscribed polygon, as you can see, it's a polygon that's inside of a circle, okay? But the important part is that all of its vertices are on the outer rim of that circle. And a circle in this case is called a circumscribed circle. So I have some more information based on that. First, our theorem 10.9, and it says, if a triangle is inscribed, I put in a triangle. If a right triangle is inscribed in a circle, let's change that right now, then its hypotenuse is the diameter of that circle. Okay? So, if the measure of, in this case, angle ABC equals 90 degrees, that would tell me that it's a right triangle. So if that's the case, then AC, the chord that's reaching all the way across, is a diameter. And vice versa. If AC is a diameter, then the measure of angle ABC has to be 90 degrees. Okay. One more theorem for you. Let me move this up. This is theorem 10.10, and it says, the opposite angles of an inscribed quadrilateral are supplementary. So this is cool. Now we have a quadrilateral that is inscribed inside of a circle, and it's saying the opposite angles, so angle F and H are supplementary, and also E and G are supplementary. So that means that the measure of angle E plus the measure of angle G add up to 180 degrees. And also the measure of angle F plus the measure of angle H also add up to 180 degrees. So that's another really cool fact. So why don't we use that to do one example? I want you, based on this diagram, to find x and to find y. So why don't we start with x? We know that the opposite angles should add up to 180 degrees. So angle S plus angle U add up to 180. If I know angle S is 100 and U is x, I simply subtract 100 and I find that x is 80 degrees. So that one's pretty easy. And same with finding y. Angle R plus angle T should add up to 180 degrees. If angle R is 60 degrees, and T is really our y, and those add up to 180, if I subtract, I find that y is equal to 120 degrees. And I'm done. So on your own, I want you to do the same thought process. I have a circle here with an inscribed polygon. It's a quadrilateral. And I want you to just find out what x and y would be. And come with that when you come back to class and any questions you might have.